All right, this is section 7.3, video 1. I'm going to do this in a number of videos, partly because there's a lot of material. So breaking it up seems like a good idea, partly because I have to think really hard to come up with questions, and I'd rather not mess up in the middle of a long video and have to start over, and partly because I have small windows in which to record. So video 1, solving polynomial inequalities. All right, so we'll start with a quadratic. And let's look at x squared minus 7x plus 12. And we want to know, when is that greater than or equal to 6? There's a couple of ways to solve this. The first thing you could do is you could graph it just to get a sense of what's going on. Actually, maybe even factor it first. That's x minus 3 and x minus 4. So it's going to look something like this, and it goes up. And if this is 6, you can see that it should be an interval, something a little smaller than 3 and something a little bigger than 4. And so now, looks like my graph is a little tilted, but now when you solve this, you should have some guidelines. So the first thing to do when solving an equation is solve the equality first. So to solve the equality first, I take my inequality and I write it as an equality, and then I solve that using the tools I have to solve quadratic equations. Subtract 6 from both sides. So you want to set it equal to 0. As opposed to solving it for a number over here. So subtract 6 from both sides. I just happen to randomly come up with something that still makes sense, x minus 1 and x minus 6. Both of those, they -1 and -6 add to -7. -1 times -6 is +6. So x equals 1 and x equals 6. Those are my 2 points here, 1 and 6. And then I just need to know when it is go. And so step 2 is look at the original inequality to determine the interval. Here I wanted it to be, greater than or equal to 6. And so I know it'd be less than or equal to 6 if I'm between x equals 1 and x equals 6. So that must be anything from -infinity up to -1, and anything from 6 going out towards +infinity. And I've solved it. All right, another way to solve this, say you don't have a graph. Let's do the same question. X squared minus 7x plus 12 greater than or equal to 6. And say you don't have a graph, or it's complicated enough that you don't want to graph it. You still solve the equality. X squared minus 7x plus 12 equals 6. X squared minus 7x plus 6 equals 0. X minus 1, x minus 6 equals 0. So x equals 1 or x equals 6. And this next step is to test points. Smaller than, between, and greater than the equality solutions. So these are the solutions to the equality solutions. So I need a point smaller than 1, between 1 and 6, and bigger than 6. So x equals 0 is a nice easy point. X equals, let's do 4. That's something between 1 and 6, and x equals 7. And so I plug each of those points into my equation. 0 squared minus 7 times 0 plus 12 equals 12. That's definitely greater than 6. If I plug 4 in, I get 16 minus 7 times 12 is 28 plus 12. That's exactly equal to 0, which is less than 6. So that doesn't work. And if I put 7 in, I get 49 minus 49 plus 12, which again happens to equal 12, which is greater than 6, and that works. All right, so all I'm looking for, I don't really care too much about what this number is. I happen to pick numbers where these two were equal, but as long as it's bigger than 6, you're okay. So I could have picked x equals 8, which would have been 64 minus 56 plus 12, which is 20, which is greater than 6, that's okay. So as long as one test point, smaller than, in between, or greater than your solutions, as long as one test point gives you a bigger than 6, then they're all bigger than 6 in this region, or less than 6, then they're all less than 6. And that's just because our functions are continuous, right? We draw without lifting. So if this is y equals 6 here, and I'm below 6 in here, I have to be below 6 everywhere until I get back up. So again, I find negative infinity up to 1, and then 6 up to infinity is where my function is bigger than or equal to 6. This works also for more higher degree polynomials. So x plus 2 times x minus 1 squared times x plus 3. And I want to know when is f of x less than 0. So if we give you these longer polynomials, I'm just looking and I'm actually seeing, I think I might have covered this in the previous video, but I'll do it again just in case. Oh, no, I see one. Okay, I see one like this. So if we give you factored polynomials, we'll always compare it to 0, because otherwise you'd have to multiply this out and then move the number over and factor it again, and we're not going to have you do that. So if it's a polynomial bigger than a quadratic, it will be compared to 0. So first you find the zeros, i.e. solve the equality. I see x minus 2, or x plus, let me start over, x equals negative 2, x equals positive 1, x equals negative 3 are the 3 zeros. So step 2, you can graph it. So first find the zeros. You have a minus 2 and a minus 3 and a positive 1. Then you have to check the multiplicities. It's a positive, or it's a multiplicity of 1 at negative 3, multiplicity of 1 at negative 2, and a multiplicity of 2 at negative 1, or sorry, positive 1. And it has a leading coefficient that's positive. So since it's got a leading coefficient that's positive, and it's a degree 1, 2, 3, 4, it must go up at both sides, and then it cuts through here, cuts through there, and bounces off, cuts through, bounces off. So it does this, and that all makes sense. And now I can just look at my graph and I say I want it to be less than 0. That's the only interval where it's less than 0, from x equals negative 2 to x equals negative 3. Or you can test points. I still like to use a number line here, but I don't have to draw my axes. I don't have to draw the whole graph. I will put the zeros on there, negative 3, negative 2, and 1. And then I'll choose a point that's smaller than, that's between, and that's bigger than my solution. So I'll try negative 4. I'll try negative 3 half, negative 2.5. I'll try 0, and I'll try 2. So if I put 4 in, and here's a nice trick. You don't have to actually calculate everything. You just have to know if the signs are positive or negative. Because you're multiplying. All right, if I put -4 in, I have -4 plus 2, that's a negative. Anything squared is a positive. -4 plus 3, that's a negative. Negative times a positive times a negative is a positive, greater than 0. If I put -2.5 in, -2.5 plus 2, that's negative. Anything squared is positive. -2.5 plus 3 is a positive, and a negative times a positive is a negative. I'm less than 0. If I put 0 in, 0 plus 2, that's a positive. Anything squared is a positive, and 0 plus 3 is a positive. So that's a positive and greater than 0. And if I put, what's my last one? 2 in, 2 plus 2 is a positive. Anything squared is a positive. 2 plus 3 is a positive. Positive times a positive is a positive, which is greater than 0. If I want it only where it's less than 0, that only happens between -2 and -3. And so my interval is -2 to -3, just like I found up here. And we'll do more of those in class. All right, that ends our recording on how to solve polynomial inequalities. We did one with a quadratic where we can factor, even if it doesn't start as factored, and so we can set it, compare it to numbers other than 0. And we did a polynomial that's already factored, and we compared it to 0 using a graph or using test points. With that little handy, I don't actually need to figure out what the number is. I just need to know if it's positive or negative. End of video.